Hello students, I am Chetan Rajoria from ABES Engineering College, Ghaziabad. I welcome you all once again to this video lecture series, and I'm going to take unit number 1 as I discussed in the 0th lecture, that is the introductory lecture. So let's start and from the very first topic, that is different types of forces and the definition of force basically. So let us see. First of all, everyone must know what is force and what is the effect of force. Force is basically an external reason because of which we can change the direction and magnitude of any moving object, or we can start movement of any stationary object in any stationary object. So the unit of the force is newtons or kilonewtons or meganewtons. It is given by Newton's second law. F is equal to ma. Mass multiplied by acceleration gives you the amount of force. It is basically a vector quantity, and direction as well as magnitude. Both the quantities are important to completely describe the nature of the force, the magnitude of the force as well as its direction. Apart from these two characteristics, there are two more characteristics of force. The third one is the point of application. At which point the force is being applied, it is described by the point of application. And the fourth characteristic is the line of action, in which direction the force is acting. Okay, so these are the four main characteristics. Now, suppose this is the object, and at this point, the force is being applied. So this is called point of application. The length of the vector represents the magnitude of the force. Inclination means angle from horizontal or vertical gives you the direction. Maybe it is being represented as theta here. And an infinite line passing through this vector represents the line of action of this force. Now, not necessary that a force is going to create only linear movement. It can create a rotation effects also, rotating effects also. Suppose there is an object which is hinged or pin jointed at this point, and we are going to apply a force at this point. Due to this, it will start creating rotation like this. It may be clockwise, and in some other case, it may be anti-clockwise also. So this turning effect of the force is measured with the help of a quantity called force moment, or simply moment. So moment is generally represented as capital M or small m. It is given by force multiplied by the perpendicular distance of the line of action of the force from the point from which we are measuring the moment. Okay, the moment is given about a particular point. So the distance between the line of action of the force and that point, perpendicular distance multiplied by the magnitude of the force, gives you this value, which is called force moment or simply moment. The unit of this quantity is Newton meters. It may be larger or smaller units also, okay, as per the need or requirement. Now, what is couple? Couple is basically a combination of two forces having same magnitude, but they are having a gap. A gap between two equal and opposite forces create a pure rotational effect, turning effect. Let's take an example of a tap. When we open or close a tap, or we open the close of a bottle cap, we apply two forces, one from finger and second one from the thumb, in clockwise or anti-clockwise direction for its opening or closing respectively. So this effect is called a couple. A couple is a combination of two forces having same magnitude but opposite direction. And it is measured in terms of this multiplication. Any one of these two forces have multiplied by the distance between these two forces. The forces are parallel, so we can measure the direct distance between these two forces. And the unit is once again Newton meter. So it provides you the pure rotation, pure turning effect. Okay, and the moment, it may be useful in the cases of bending of beams when the force is applied at one point and the beam is supported at some other point, so this gap will create a bending effect in the beam. So in case of bending of the beams especially, we will discuss this term, that is the moment. Next one is the principle of transmissibility, which is a very basic theorem. Let's see what is this. The statement of principle of transmissibility is that any force can be transferred along its line of action within the limits of the object, and there will be no change in its effect. The effect of the force initially was any type of effect was there initially. So after that transferring of the force along its line of action, there will be no change in its effect. So let's take an example. Suppose there is an object. If I am applying a force here, so as per this theorem, or as per this statement of principle, as per this principle, this force can be transferred anywhere along its line of action. It can be shown here also. It can be shown here also. It can be shown at this point also. The effect will be same. There will be no change in its effect. So how can we prove it? We can prove it very simply, in a simple way, logically. Suppose this is the object, and a force is being acted here. This is the force having magnitude F. Now I'm arbitrarily choosing another point along its line of action. Suppose this is the point on which I'm going to study the effect of two forces, equal and opposite. The magnitude of these two forces is F. So there will be no change in its effect because the nature of, or you can say the magnitude of these two forces are equal, but the direction is opposite. So the net effect of these two forces will be null and void. Okay, zero. So ultimately, the only one effective force is there, the initial one, which I described earlier. Now, if we couple up these two forces together, clearly we can see that these two forces are canceling out each other. So if we remove these two forces, only one force will be there in that case, at object, and only one force is there. Because first and second forces has been cancelled out because of their opposite directions and equal magnitude. So we can see that initially the force was here, as I described earlier. The force was initially here, and now we have transferred this force along its line of action at some other point. The initial point was A, and now the final point is, say, B. The net effect is same in both of these figures, this one as well as this one. So this is called principle of transmissibility. It is one of the most fundamentals and most important theorem in the fields of statics. Next is types of force system and its classification. There are different types of forces. The forces may be concurrent and non-concurrent. There is one more classification. The forces may be coplanar and non-coplanar. Coplanar forces are those forces in which the complete vector of all the forces in that system are lying in a single plane. Okay, the forces are acting in a single plane only. That type of force system is called a coplanar force. And just opposite, if there are at least one force is there in having the direction outside or inside a plane, means the line of action of different forces are not in a single plane. That type of force system is called a non-coplanar force system. Now let's come to this classification, concurrent and non-concurrent. As the name suggests, there may be a few forces in which the line of action of all the forces is passing through a single point, like this. You can see here, there are 5 forces which are acting at a single point only. All these 5 forces, line of action is passing through this point. This is called a concurrent force system. And contrary to this system can be considered as a non-concurrent force system, in which the line of action of all the forces are not passing through a single point only. There may be different intersection points, but all forces are not passing through a single point. So this is a non-concurrent force system. Coplanar and non-coplanar, I already discussed. So there may be some combinations of these type of force systems. It may be a coplanar concurrent force system. It may be a coplanar non-concurrent force system. Another may be non-coplanar concurrent force system, non-coplanar non-concurrent force system. So in this way, various types of force systems are possible. One more type or category is there. It may be a parallel force system. And parallel force system is of two types, like and unlike. If the direction of all the parallel forces are in the same direction, like this, right hand side or left hand side, or in the same direction, it's called a like parallel force system. Otherwise, if forces are acting in opposite directions like this type of parallel assembly of forces is called unlike parallel force system. We can classify one more type of force system in which the forces are having same line of action. These two forces, F1 and F2, are having same line of action. This is called a collinear force system. Okay, it may be two or more than two forces having same line of action. So this is called collinear force system. So let's conclude. What are the types of forces? It may be a coplanar concurrent force system, coplanar non-concurrent force system, non-coplanar concurrent force system, non-coplanar non-concurrent force system, like parallel force system, unlike parallel force system, and collinear force system. Now, what are the conditions of static equilibrium? If there are number of forces which are acting on an object and the object is stationary, it is not moving at all, it means the net summation of all the forces must be equal to 0. Okay, so if there is a concurrent force system, in that case, the desired conditions of static equilibrium is summation of forces along x-axis should be equal to 0 and summation of forces along y-axis should be equal to 0. Only these two conditions are enough. Only in case of concurrent force system. But in case of non-concurrent force system, summation of forces along x-axis should be equal to 0. Summation of forces along y-axis should be equal to 0. And third condition, summation of all the moments about any point should also be equal to 0. These three conditions must be there to make sure that the object will not move. There will be no translatory movement. There will be no rotatory or angular displacements will be there. No movement will be there. So to make sure this, we need these conditions for non-concurrent and these conditions for concurrent force system. These are called the conditions of static equilibrium. And what is Lamy's theorem? It is a well-known theorem. So what is Lamy's theorem? If there are three forces, coplanar, concurrent force system is there. So if three coplanar concurrent forces are acting at a particular object, concurrency is there. In that case, suppose this force is F1, F2, and F3. Angle is alpha, beta, and gamma. So as per this theorem, F1 upon sine beta is equal to F2 upon sine gamma is equal to F3 upon sine alpha. So what will be the statement? It states that if three forces are in equilibrium, the forces are coplanar and concurrent. In that case, the ratio of any force and the sine of the angle between other two forces remains constant. So this is called Lami's theorem. It is a very important theorem for solving various problems based on static equilibrium. Anywhere, if we found that there are three forces and the forces are concurrent and the object is not moving, static equilibrium condition is there. So we can apply this theorem. If suppose this force is to be found and this is known, so using first and third, we can find the value of F1. Similarly, we can find the value of F2 also using second and third if F3 is known. So in this way, in only few lines, we can find the unknown values. So students, that's all for this lecture. We covered up different types of forces, the fundamentals of force, couple, principle of transmissibility, classification of force system, conditions of static equilibrium, and Lami's theorem. So thank you so much, students. These are the few references which I used here. Thank you so much.